On June 15, 1943, at a breathtaking altitude of 25,000 feet above the churning expanse of the English Channel, the renowned German aerial ace, Klaus Brenner, narrowed his gaze through the clear canopy of his agile Messerschmitt fighter, his eyes fixed upon an approaching American aerial formation, a flight of 8 P-47 Thunderbolts, those bulky, cumbersome aircraft often derisively likened to flying milk bottles, which the formidable Luftwaffe had been effortlessly dispatching from the European skies for many months. A confident smirk played across Brenner's lips. He knew these thunderbolts ascended with the sluggishness of heavily loaded freight trains, achieving a maximum climb rate of barely 1,500 feet per minute, a stark contrast to his nimble Messerschmitt 109, which could gracefully outmaneuver them in any vertical engagement. This encounter, he mused, promised to be yet another straightforward aerial victory. However, as Brenner initiated his characteristic attack dive, an utterly astonishing and unprecedented event unfolded. The leading P-47, rather than attempting to evade or execute a defensive turn, unexpectedly pitched its nose upwards into an ascent so incredibly aggressive that it completely defied every piece of intelligence the Luftwaffe had painstakingly gathered about American fighter capabilities. This massive aircraft, with an almost defiant roar, clawed its way skyward at an astonishing rate of nearly 2,000 feet per minute, its powerful engine screaming at its absolute limit, actively pursuing Brenner into what he had always considered his undisputed aerial domain. Within the confines of his cramped Messerschmitt cockpit, the German pilot experienced a chilling sensation, his very first pang of true fear, as the American propeller, a revolutionary 13-foot marvel of paddleblade engineering, transformed what was once a source of aerial jest into the most terrifying predator he had ever encountered in the vast expanse of the sky. Please stay with us and watch the end of the video. We will be grateful for your like and subscription. And also please write a comment about where you are from and what you think about the video topic. The unfolding morning reports from the European theater presented a stark and unsettling reality, a grim panorama that no amount of optimistic rhetoric emanating from the Pentagon could possibly obscure. By the pivotal month of September 1943, the P-47 Thunderbolt had unfortunately cultivated a reputation so dire that even the most seasoned and courageous American pilots were actively requesting transfers to any other winged aircraft available, desperate to avoid flying the Jug. This derogatory nickname, originally coined by Luftwaffe pilots due to its distinctive milk bottle-like silhouette, had not only permeated enemy lines, but now echoed with a profound and bitter irony through the very Allied briefing rooms where strategies for victory were supposed to be forged. Colonel James Johnson, a man whose responsibilities weighed heavily on his shoulders, methodically leafed through the most recent combat assessment reports at Wright Field. His untouched coffee, once steaming, grew progressively colder beside him, its warmth dissipating as the relentless and unforgiving statistics laid bare their brutal narrative. The P-47's inherent climb rate, a mere 1,500 feet per minute, rendered it an almost defenseless target, a proverbial sitting duck, against the superior Messerschmitt 109s, which possessed the formidable capability to ascend at a blistering pace exceeding 3,000 feet per minute. In the intense aerial dogfights raging over the skies of occupied France, German pilots had shrewdly devised a remarkably straightforward yet devastatingly effective tactic. They would simply climb above the Thunderbolts, gaining a decisive altitude advantage, and then proceed to meticulously pick them off with disquieting ease. The immense American fighter, a behemoth weighing in at more than 7 tons when fully loaded with fuel and ordnance, was fundamentally incapable of following enemy aircraft into the crucial vertical dimension, the very realm where the fate of modern air combat was decisively determined. Meanwhile, in his somewhat confined office, situated within the Hamilton Standard Division, Frank Caldwell, a veteran engineer of considerable experience, meticulously scrutinized the very same disheartening reports. However, where military commanders perceived an unequivocal failure, Caldwell, with his profound understanding of aeronautical principles, discerned a fundamental issue of physics. The formidable Pratt & Whitney R2800 double wasp engine, powerfully ensconced within the nose of the P-47, generated an astounding 2,300 horsepower, a sheer, unadulterated output of raw power that surpassed any other fighter engine globally. Yet, despite this colossal energy, it was inexplicably being squandered. Caldwell's insightful analysis concluded that the root of the problem lay neither with the engine itself nor with the aircraft's robust airframe. Rather, the critical flaw resided in the narrow-bladed propeller, which proved utterly incapable of efficiently absorbing and subsequently translating that immense torque into effective forward thrust. For generations, the principles guiding traditional propeller design had largely persisted without significant alteration since the tumultuous era of the Great War. Engineers had meticulously crafted these propellers with slender, knife-like blades, specifically engineered to cut through the air with optimal efficiency primarily during cruising speeds. However, this prized efficiency at a steady cruise became utterly inconsequential when the exigencies of combat demanded an immediate and sustained maximum power output. The P-47 standard propeller blades, measuring a mere 11 feet in diameter, were simply inadequate to effectively handle the prodigious output of the R2800 engine without a severe degradation in their performance. When operating at full throttle, the tips of these blades approached supersonic velocities, inadvertently generating destructive shock waves that not only annihilated aerodynamic lift, but also effectively transformed the propeller into an expensive, power-sapping air brake, severely hindering the aircraft's potential. The audacious solution that began to crystallize within Caldwell's brilliant mind fundamentally challenged and indeed violated every established principle of conventional propeller design. Instead of adhering to the conventional wisdom of thin blades meticulously optimized for the delicate balance of cruise efficiency, he boldly envisioned broad, paddle-shaped blades. These innovative blades, he theorized, would possess the unprecedented capacity to aggressively seize massive volumes of air and, with an almost brutal force, hurl it backward, generating immense thrust. This revolutionary concept bore a striking resemblance to a boat propeller, rather than a typical aircraft prop. Its blades were thick, remarkably wide, and possessed an almost clumsy appearance, unequivocally prioritizing raw, unadulterated thrust over any semblance of elegant aerodynamic efficiency. Caldwell's esteemed colleagues at Hamilton Standard listened to his radical proposal with a mixture of professional courtesy and underlying skepticism. Tom Richards, the division's highly respected senior aerodynamicist, promptly highlighted a series of undeniable practical challenges. the inevitable increase in overall weight, the anticipated surge in aerodynamic drag during cruising speeds, and the formidable manufacturing complexities that would render mass production an almost insurmountable task. The military, he reminded them, had already invested millions of dollars into the existing infrastructure and specialized tooling for current propeller designs. The prospect of retooling entire production lines for an unproven experimental design would not only incur a colossal financial outlay, but also inevitably cause significant delays in aircraft deliveries, potentially stretching for many months, a critical setback in wartime. Undeterred by the skepticism, Caldwell had meticulously performed all the necessary calculations, confirming his hypothesis. He confidently asserted that a 13-foot diameter propeller, specifically equipped with his innovative paddle blades, would possess the remarkable capability to fully absorb the entire 2,300 horsepower output of the R-2800 engine. This anticipated increase in thrust, he demonstrated, would more than adequately overcome any additional drag generated by the larger blades. Furthermore, the increased diameter itself would significantly reduce the tip speeds of the blades, thereby entirely eliminating the problematic shockwave phenomenon that had so severely plagued existing propeller designs. Crucially, and perhaps most importantly, Caldwell's new propeller promised to fundamentally transform the P-47's notoriously abysmal climb rate into a performance metric that could not only compete, but potentially even surpass the capabilities of contemporary German fighters. The pervasive skepticism regarding Caldwell's radical design was not confined solely to the engineering staff at Hamilton Standard. Across the competitive landscape at Curtiss Electric, Hamilton's primary rival for lucrative military propeller contracts, senior engineer Robert Hayes summarily dismissed the paddleblade concept. He derided it as nothing more than a desperate last-ditch attempt to salvage an aircraft he considered inherently unfixable. Curtiss, for its part, was actively developing its own proprietary solution, a refined iteration of their existing narrow blade design, which incorporated improved pitch control mechanisms and a marginally larger diameter. Their approach was inherently conservative, grounded in proven technology, and, crucially, could be manufactured seamlessly using existing tooling, thereby minimizing risk and production disruptions. The U.S. Army Air Forces found itself in an unenviable predicament, caught precariously between two fundamentally opposing philosophical approaches to propeller design. On one side stood the conservative approach, which promised incremental, measured improvements with the allure of minimal risk and manageable costs. On the other, the radical approach, which held the tantalizing promise of revolutionary performance gains, yet was simultaneously fraught with enormous technical and financial uncertainties. Colonel Johnson, burdened with the critical responsibility of thoroughly evaluating both proposals, confronted a monumental decision, one that would inevitably impact the lives and combat effectiveness of thousands of American pilots preparing to engage in the brutal aerial battles over the skies of Europe. Meanwhile, across the vast expanse of the Atlantic, Luftwaffe intelligence officers were diligently tracking American aircraft development with their characteristic German thoroughness and meticulous attention to detail. Major Wilhelm Speck, who was strategically stationed at a Luftwaffe technical evaluation center nestled in occupied France, had personally conducted exhaustive examinations of several captured P-47s. His subsequent reports dispatched to Berlin were unequivocally dismissive in tone. He concluded that the American fighter was nothing more than a brute force design, heavily reliant on its substantial armor plating and immensely powerful engines to compensate for what he perceived as its fundamentally poor aerodynamic qualities. Consequently, German pilots, he confidently asserted, could continue to exploit the P-47's sluggish climb rate and its inherent lack of maneuverability indefinitely, maintaining their aerial superiority. The unwavering conviction held by Speck was echoed throughout the echelons of the German Air Force leadership. While the Americans had demonstrated an undeniable aptitude for rapid, large-scale aircraft manufacturing, they appeared utterly deficient in replicating the refined ingenuity of German aeronautical design. The P-47 Thunderbolt, in their estimation, epitomized the perceived shortcomings of American aircraft conception, a gargantuan, cumbersome, unrefined, and ultimately wasteful machine. German pilots wryly likened the act of downing a Thunderbolt to the simple pursuit of an airborne refrigeration unit, a target both effortlessly located and guaranteed to succumb upon impact. The pivotal September test flights at Wright Field were poised to decide the guiding engineering doctrine that would arm American aerial combatants for the impending crucial engagements. Frank Caldwell's pioneering paddleblade propeller had been affixed to a singular P-47D model for an initial assessment. The aircraft, resting on the aerodrome's flight line, presented an almost farcical silhouette. Its colossal propeller blades evoked the image of an apparatus more suited to a heavy transport aircraft rather than a nimble fighter. Test pilot Captain Robert Anderson ascended into the pilot's seat, tasked with the mandate to subject the airframe to its absolute operational extremes and meticulously record any alterations in its performance. As Anderson taxied toward the runway, neither the aviator nor the technical experts observing from the aerodrome's control tower possessed the foresight to comprehend that they were about to witness the imminent metamorphosis of what was widely considered the greatest letdown in airborne combat into its most dreaded assailant. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment about where you are from and what you think about the video topic. The established aeronautical dogma that had influenced the trajectory of fighter aircraft conception for 2 full decades stood on the precipice of utter demolition, poised to be shattered by a mere 13 feet of ground-breaking mechanical innovation that would fundamentally redefine the parameters of aerial engagement across the European theater. The maiden test flight on October 12th extended for precisely 14 minutes before Captain Anderson guided the modified P-47 back to Wright Field, delivering an unsettling account of intense structural oscillation. The massive paddle blades had, in operation, engendered resonant vibrations pervading the entire aircraft structure, imperiling the machine's structural integrity and portending its disintegration at any power setting exceeding 70% of maximum thrust. Frank Caldwell observed from the control tower as maintenance personnel converged rapidly upon the airframe, diligently inspecting for signs of material fatigue and dislodged fasteners. The issue of structural oscillation did not come as a complete surprise. Propeller harmonics had been a persistent affliction within aeronautics since its very inception with the Wright siblings. However, the sheer ferocity of this particular vibration indicated inherent deficiencies in the blade design. Caldwell's dedicated team spent the ensuing 3 weeks meticulously re-engineering the blade's foundational anchorage mechanism and recalibrating the propeller's central hub equilibrium. The initial blades had been fabricated utilizing conventional techniques that functioned impeccably for slender-bladed configurations, yet demonstrated utter insufficiency when confronted with the colossal forces generated by the paddle geometry. Each blade possessed a mass nearly twice that of conventional designs, consequently generating torsional strains beyond the capacity of the standard hub. The definitive solution necessitated specially fabricated blade shafts and an entirely re-engineered central hub apparatus, which collectively contributed an additional 200 pounds to the aircraft's forward mass. The subsequent test flight on November 5th yielded outcomes that, while distinct, proved equally disheartening. Although the issue of structural oscillation had been successfully addressed, the new propeller's operational metrics significantly underperformed Caldwell's preliminary computations. Instead of the anticipated ascent velocity enhancement to 2,900 feet per minute, Anderson recorded a mere 1,600 feet per minute, representing a marginal gain of just 100 feet per minute compared to the conventional propeller system. The increase in maximum velocity was equally underwhelming, with the aircraft attaining a speed of only 410 miles per hour against the established benchmark of 400 miles per hour. Robert Hayes, representing Curtiss Electric, assimilated the disheartening trial data with an ill-disguised sense of gratification. His team's meticulously optimized slender blade configuration had completed its own initial testing the previous week, reporting substantially more encouraging statistics. The Curtiss propeller achieved an ascent rate of 1,750 feet per minute and preserved the airframe's established maximum velocity, all devoid of the compensatory mass increase or the intricate production challenges inherent in Caldwell's paddleblade design. Hayes promptly transmitted his findings to Colonel Johnson, accompanied by a memorandum intimating that Hamilton Standard's revolutionary methodology had unequivocally demonstrated itself to be an expensive cul-de-sac. However, Caldwell harbored a strong conviction that the root of the issue resided not in the fundamental paddle blade principle, but rather in the propeller's specific pitch configurations and the refinement of its blade angles. The preliminary blueprint had been predicated upon abstract computations that presupposed flawless operational environments. Empirical flight trials unequivocally demonstrated that the ideal blade inclination for superior ascent performance diverged considerably from the angle conducive to achieving peak horizontal flight velocity. The P-47's existing constant-speed propeller system possessed the capability to automatically adjust pitch during flight, but the scope of its adaptability had been specifically calibrated for propellers featuring slender blades. Engaging in arduous 18-hour workdays within Hamilton Standard's engineering lab, Caldwell's dedicated team engineered a novel, constant-speed propulsion mechanism boasting double the pitch modulation capability of existing systems. This crucial modification necessitated substantial alterations to both the propeller's governing unit and its hydraulic actuation systems, but it would ultimately enable the paddle blades to function at their most efficient inclinations throughout the full spectrum of flight conditions. The comprehensively redesigned system possessed the capacity to transition seamlessly from a broad-angle pitch configuration, ideal for high-velocity cruising, to an exceptionally acute pitch, designed to generate maximum static thrust during both ascent and initial liftoff. The array of technical hurdles extended far beyond the confines of simple pitch regulation. The augmented superficial area of the paddle blades generated significant thermal management issues for the power plant, while the expanded propeller disc drew a greater volume of air through the engine's protective cowling. This airflow was paradoxically retarded in velocity owing to heightened aerodynamic drag. Operating temperatures within the engine ascended to perilously elevated levels during prolonged periods of maximum power output, imperiling the structural integrity of the R-2800's cylindrical components. Consequently, Caldwell's team was compelled to comprehensively re-engineer the cowling's air induction apparatus and incorporate supplementary cooling vents to consistently maintain proper engine temperatures. Lieutenant Colonel Johnson was confronted with intensifying scrutiny and considerable pressure from high-ranking Pentagon functionaries who openly challenged the wisdom of sustained financial commitment to the P-47 development initiative. Concurrently, the Boeing P-51 Mustang was demonstrating extraordinary potential during its preliminary evaluation phases, exhibiting operational metrics that eclipsed not only the conventional P-47 but also the anticipated enhancements of the paddle blade adaptation. Some influential officials vociferously argued that capital and effort would be more judiciously allocated to expediting the manufacturing of the P-51 rather than persisting in endeavors to rectify the inherent deficiencies of the Thunderbolt. The pivotal third test flight, conducted on December 8th, finally unveiled the true capabilities of the innovative paddleblade propeller. Equipped with a refined pitch control system and an expertly redesigned cooling mechanism, test pilot Anderson skillfully maneuvered the modified P-47 through an intricate series of combat simulations. These aerial acrobatics would have been utterly unattainable with the aircraft's standard configuration. The Thunderbolt impressively ascended to an altitude of 20,000 feet in a mere 10 minutes and 40 seconds, achieving a remarkable climb rate of 1,850 feet per minute, a performance figure that rivaled even the most advanced German fighter aircraft of the era. What made this achievement even more extraordinary was the fact that the P-47 sustained this impressive climb rate while burdened with its full combat complement, including its heavy armor plating, a complete load of ammunition, and a full tank of aviation fuel. The subsequent speed trials yielded results that were equally encouraging and indicative of a significant leap in performance. At a cruising altitude of 25,000 feet, the enhanced P-47 attained a blistering speed of 445 miles per hour in level flight. This represented a substantial 45 mph improvement over the baseline configuration of the aircraft. Crucially, this increase in velocity did not stem from a reduction in aerodynamic drag, but rather from the paddle blade propeller's superior efficiency in converting the raw power generated by the engine directly into forward thrust. Particularly at higher altitudes, where the atmospheric density naturally decreases, the paddle blade's exceptional ability to grip the thinner air provided a decisive and undeniable advantage over conventional propeller designs, which typically struggled in such conditions. However, the most profound and potentially life-saving discovery emerged during the rigorous dive recovery tests. The P-47 had long been plagued by a notorious characteristic: its inherent reluctance to pull out of high-speed dives, a limitation that often placed pilots in perilous situations. The original narrow blade propeller simply could not generate sufficient thrust to counteract the immense momentum and considerable weight of the aircraft during such extreme maneuvers. Anderson's groundbreaking finding was that the paddle blade propeller, when set to its fine pitch configuration, generated enough reverse thrust. This critical capability effectively aided the aircraft in decelerating and subsequently recovering from dives that, with the original propeller setup, would have undoubtedly resulted in fatal outcomes. We invite you to stay with us and watch the conclusion of this compelling video. Your like and subscription would be greatly appreciated. Please also share a comment below, letting us know where you are watching from and your thoughts on the crucial topic discussed in this video. In stark contrast to these promising American findings, German intelligence reports from late December painted a dismissive picture of the modified P-47, characterizing it as an intriguing but ultimately inconsequential development. Luftwaffe analysts acknowledged that the Americans were indeed experimenting with larger propellers on their fighter aircraft. Yet they summarily dismissed these modifications as desperate and ultimately futile attempts to enhance what they perceived as an obsolete design. Major Spec's comprehensive assessment concluded with the firm belief that even with these propeller improvements, the P-47 remained inherently inferior to German fighters across virtually every performance category, with the singular exceptions of its straight-line speed and its impressive diving capabilities. Despite the German skepticism, the compelling December test results decisively persuaded Colonel Johnson to authorize a limited production run of the paddleblade propeller, specifically for operational testing in a combat theater. Hamilton Standard, a leading propeller manufacturer, was subsequently awarded a contract for 50 propeller units. These units were earmarked for installation on P-47 D-22 aircraft, which were slated for deployment to the European Theater of Operations in early 1944. This order represented a substantial gamble, fraught with immense risk. Should the paddle blade design falter in the crucible of actual combat, American pilots would tragically bear the ultimate cost with their lives. Undeterred, Caldwell's dedicated team labored tirelessly throughout the Christmas holiday season, meticulously preparing the specialized production tooling and thoroughly training manufacturing personnel on the intricate new assembly procedures required for the innovative design. Each paddle blade propeller demanded an astonishing 40% more manufacturing time than its conventional counterparts, and incurred nearly double the production cost. The financial exposure was undeniably enormous, but the potential payoff, the profound transformation of the P-47 into a truly competitive and formidable fighter aircraft, unequivocally justified this significant investment. As the new year of 1944 dawned, the very first production paddle blade propellers began their journey from Hamilton Standard's factory. Their destination was a network of modification centers, where they would be meticulously installed onto the Thunderbolts destined for the European theater of war. At that nascent stage, neither the astute American engineers who had painstakingly brought them into existence, nor the formidable German pilots who would soon confront them in aerial combat could possibly fathom the profound and complete extent to which these 13 feet of revolutionary engineering would irrevocably alter the delicate balance of air power in the embattled skies over occupied Europe. The eagerly anticipated arrival of the first paddle-blade-equipped P-47s at RAF Boxted on March 15, 1944, immediately ignited a significant controversy among the battle-hardened veteran pilots of the 356th Fighter Group. Captain Mike Gladys, a distinguished Polish exile, and an ace with 12 confirmed aerial victories, scrutinized the massive, unconventional propeller blades with undisguised skepticism. To his experienced eye, the blades appeared crude and disproportionately oversized when compared to the sleek, narrow propellers he was accustomed to flying. Such was the initial apprehension that several pilots quickly nicknamed the modified aircraft barn door specials and promptly requested permission to continue operating their standard Thunderbolts until the new design could unequivocally prove its mettle in the harsh realities of combat. Group Commander Colonel Harold Ralph found himself in an exceptionally delicate and precarious situation. His seasoned pilots had endured and survived months of brutal, unforgiving air combat, a feat achieved through their exceptional skill, unwavering courage, and an intimate, almost instinctive understanding of their aircraft's precise capabilities and inherent limitations. Forcing these invaluable aviators to transition to and fly unfamiliar equipment carried the profound and potentially fatal risk of catastrophic failure. However, the operational orders emanating from 8th Air Force Headquarters were explicit and unambiguous. The modified P-47s were to be evaluated under actual combat conditions as swiftly as humanly possible. The ultimate success or failure of Caldwell's groundbreaking paddleblade design would not be determined within the controlled confines of test flights, but rather in the crucible of life-or-death encounters with veteran Luftwaffe pilots high above the contested skies of occupied Europe. The inaugural combat mission for these modified Thunderbolts unfolded on March 22nd during a critical bomber escort mission targeting the German capital of Berlin. Gladys, leading a flight of 4 paddle-blade P-47s, provided high-altitude cover for a formation of B-17 flying fortresses as they approached the formidable German metropolis. At an altitude of 30,000 feet, positioned well above the bomber stream, Gladys's sharp eyes detected a formation of Bf-109s diving menacingly from 35,000 feet, executing a classic bounce attack. Under normal operational circumstances, the P-47s would have been compelled to dive away from the German fighters, leveraging their superior speed in a descent to escape the Bf-109's inherent climb advantage. Instead, in a bold and unprecedented move, Gladys pulled his flight into a steep, aggressive climb, directly intercepting the diving Messerschmitts. The paddle-blade propellers, demonstrating an unprecedented authority, clawed through the thin, rarefied air at altitude, maintaining an astonishing climb rate of over 7,700 feet per minute, even at 30,000 feet, an altitude where standard propellers would have struggled to achieve even half that performance. The German pilots, fully expecting the American fighters to disengage and dive away, were utterly astonished to find themselves facing P-47s climbing directly into their attack path, possessing more than enough energy to engage in sustained turning combat at such extreme altitudes. The ensuing engagement, though lasting less than 3 minutes, irrevocably shattered German assumptions regarding American fighter capabilities, deeply held beliefs that had persisted unchallenged for over 2 years of continuous combat. Gladys's wingman, Lieutenant Robert Johnson, remarkably managed to stay locked in a close-quarters engagement with a Bf-109 through a series of strenuous climbing turns, maneuvers that would have been utterly impossible with the standard propeller configuration. The Messerschmitt pilot, Major Hans Dormann, later reported to Luftwaffe intelligence that the American fighter had exhibited climb performance entirely equal to that of German aircraft, a claim that was, perhaps predictably, initially dismissed by his superiors as the product of combat stress or a simple pilot error. The news of this particular aerial confrontation rapidly disseminated among the various Luftwaffe fighter squadrons deployed across Western Europe. For a considerable period, German aviators had meticulously crafted their combat strategies, predicated on the absolute conviction that their aircraft possessed an inherent advantage in ascensional performance, thereby enabling them to initiate and control aerial battles from a commanding position at higher altitudes. The unsettling prospect that P-47s might now possess the capability to contend effectively in vertical flight maneuvers posed a severe challenge, potentially rendering obsolete years of accumulated combat wisdom and established tactical principles. Consequently, numerous squadron leaders promptly sought urgent verification regarding the purported American fighter alterations from their intelligence agencies. On April 2nd, Major Wilhelm Speck, leading a specialized technical intelligence detachment, secured their initial paddleblade-equipped P-47. This occurred when Lieutenant Charles Morrison was compelled to execute an emergency landing near Calais, his aircraft having sustained significant damage from anti-aircraft fire during a ground assault operation. Although Lieutenant Morrison adeptly rendered much of his aircraft's classified apparatus inoperable prior to his apprehension, the distinctive propeller assembly remained undamaged, allowing for thorough German scrutiny. Major Speck's preliminary assessment characterized the paddle blades as excessively large and speculated that this alteration would likely introduce more operational complications than it would resolve. However, the subsequent comprehensive technical examination unveiled the remarkable ingenuity inherent in Caldwell's engineering. German aeronautical experts ascertained that these paddle blades integrated cutting-edge metallurgical compositions and highly accurate manufacturing processes, surpassing anything currently achievable within the Luftwaffe's own production capabilities. Furthermore, the constant speed propeller mechanism exhibited novel advancements in hydraulic regulatory systems, technologies that German engineers had not yet successfully pioneered. Perhaps most disconcerting was the profound understanding that the Americans had successfully overcome challenges related to propeller efficiency, issues that German technical minds had previously deemed insurmountable, given the prevailing technological constraints. We invite you to stay with us and watch the end of this insightful video. Your like and subscription would be greatly appreciated. Please share in the comments where you are from and your thoughts on the video's topic. Throughout April and extending into early May, dispatches from the front lines depicted an progressively bleak scenario for Luftwaffe aerial engagements across Western Europe. American P-47s were now routinely initiating and winning dogfights that involved ascending maneuvers against German adversaries. The 356th Fighter Group, for instance, reported the destruction of 21 German aircraft solely in April, with a significant majority of these triumphs stemming from confrontations that conventional P-47s, lacking the new modifications, would unequivocally not have been able to endure. The toll on German pilot personnel was escalating precipitously as their long-held altitude superiority, which formed the fundamental bedrock of Luftwaffe fighter doctrine, progressively diminished into obsolescence. The strategic ramifications of these developments transcended mere individual aerial duels. German Fighter Command had historically deployed their aircraft with the express purpose of assailing American bomber formations from a superior vantage point, confident in the knowledge that the accompanying P-47 escorts lacked the requisite climb rate to effectively thwart these swift, high-to-low bounce attacks. However, the introduction of the paddleblade propellers empowered American fighters to steadfastly maintain their positions at the same operational altitude as the bombers, thereby enabling them to instantaneously counter German assaults from any vector. Consequently, Luftwaffe missions designed for bomber interception, which had previously achieved success largely due to their inherent altitude superiority, now encountered prompt and vigorous resistance from American escort fighters operating at their peak combat readiness. By the middle of May, virtually every P-47 deployed on the front lines within the European theater of operations had been retrofitted with the revolutionary paddleblade propellers. The extensive modification initiative had successfully surmounted its preliminary production hurdles and was now generating these crucial propeller units at an impressive pace of 200 per month. The Hamilton Standard Manufacturing Facility in Connecticut maintained a continuous, round-the-clock operational schedule to satisfy the urgent military requisitions. Concurrently, Caldwell's dedicated engineering cadre collaborated directly with the manufacturing staff, diligently working to optimize production methodologies and eradicate any emerging quality control deficiencies. As the month drew to a close, the quantitative data unequivocally affirmed the profound influence of the paddleblade technology. P-47 squadrons outfitted with these innovative propellers documented a substantial 40% augmentation in their air-to-air victory ratios when contrasted with the performance metrics of the identical units utilizing conventional propellers. Even more critically, the attrition rates for P-47s had seen a notable reduction of 30%, a direct consequence of pilots acquiring the enhanced capability to ascend rapidly out of perilous encounters, rather than being exclusively dependent on sheer diving velocity for evasive maneuvers. Clearly, the formidable Thunderbolt had ceased to be the Luftwaffe's favored prey. In the latter part of May, Colonel Johnson was granted official sanction to broaden the paddleblade modification initiative to encompass all existing P-47 variants currently undergoing production. The resounding triumph achieved in the European theater had thoroughly persuaded Pentagon strategists that Caldwell's seemingly audacious, stupid propeller trick actually constituted one of the most pivotal technological advancements of the entire conflict. Directives were subsequently issued to retrofit existing P-47 aircraft stationed in the Pacific Theater, and to ensure that all newly manufactured aircraft were fitted with paddle-blade propellers directly from the assembly line. German intelligence personnel found themselves grappling with the formidable challenge of elucidating the abrupt and dramatic enhancement in American fighter capabilities to Luftwaffe High Command, who had, over time, become firmly entrenched in the belief of their tactical ascendancy over Allied air power. Major Wilhelm Speck's revised intelligence communiques conceded that the Americans had indeed secured a substantial technological edge. However, German aircraft engineers were hampered by an acute scarcity of both manufacturing infrastructure and essential raw materials. precluding their ability to devise comparable propeller enhancements. Consequently, the Luftwaffe was compelled to confront the remainder of the conflict with the stark realization that their fighter aircraft could no longer assert dominance over American adversaries by virtue of superior climb performance and a commanding altitude advantage. The profound shift in aerial dynamics was now fully realized. Frank Caldwell's innovative paddleblade propeller had fundamentally transmuted the P-47 Thunderbolt from being a favored target for the Luftwaffe into their most formidable adversary, thereby completely redrawing the strategic equilibrium of aerial warfare across Europe. This monumental shift occurred mere months prior to the impending D-Day invasion, an operation that would unequivocally necessitate absolute Allied air supremacy. The dawn of D-Day presented the definitive crucible for Frank Caldwell's engineering revolution as an impressive contingent of nearly 400 P-47s, all fitted with the paddleblade propellers, roared across the English Channel on the morning of June 6, 1944. This colossal aerial formation, charged with the critical mission of establishing Allied air superiority over the Normandy landing zones, comprised a greater number of modified Thunderbolts than had ever been deployed in any preceding operation. Their conspicuously broad propeller blades gleamed as they caught the inaugural rays of light on what would undeniably become the most protracted day in the annals of aviation. Colonel Francis Gabreski spearheaded the 56th Fighter Group's reconnaissance sweep above Omaha Beach at precisely 0630 hours. His squadron of 16 P-47s ascending to a formidable altitude of 25,000 feet with a commanding authority that would have been utterly unattainable just half a year prior. Beneath this aerial spectacle, the most expansive, amphibious invasion ever conceived in human history was meticulously unfolding, with Allied landing craft steadily converging upon the heavily fortified coastline of France. Concurrently, in the skies overhead, German fighter aircraft were notably, almost eerily, absent from an airspace they had previously controlled with unchallenged supremacy. The Luftwaffe's conspicuously limited reaction to the monumental invasion vividly underscored the catastrophic consequences that the paddleblade revolution had inflicted upon established German tactical methodologies. Oberst Adolf Galland, who commanded the Luftwaffe's fighter forces across the Reich, found himself compelled to abandon the well-established altitude advantage tactics that had consistently served German pilots with such effectiveness since the earliest stages of the Battle of Britain. His formidable fighters could no longer reliably depend on outclimbing American escort aircraft to launch their preferred high-altitude assaults on Allied bomber formations. Instead, German airmen were increasingly forced into engagements at lower altitudes, a combat environment where the P-47 Thunderbolt's inherent strengths, its formidable firepower and robust armor plating, provided American pilots with decisive and often insurmountable advantages. Major Klaus Matuschia's Jagdgeschwader, a renowned fighter wing, received explicit orders to intercept Allied fighter bombers that were relentlessly attacking German ground positions in the vicinity of Caen. However, the fundamental tactical situation had undergone a profound and irreversible alteration since the revolutionary paddleblade modifications began to appear and proliferate across the European theater. Matuschia's Focke-Wulf FW 190s, which had once demonstrated a superior capability to ascend above American fighters and thereby dictate the terms of aerial engagements, now found their vertical performance either matched or, more frequently, surpassed by the enhanced Thunderbolts. These advanced P-47s could maintain their combat effectiveness and maneuverability across a much broader spectrum of altitudes, effectively neutralizing the FW-190's traditional climbing dominance. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. The morning's inaugural major air battle developed dramatically over the critical invasion beaches when a formation of 24 Messerschmitt Bf-109s attempted a concerted attack on Allied naval forces that were providing indispensable support for the landings. Captain Robert Johnson, leading a flight of 8 paddleblade-equipped P-47s, skillfully intercepted the German formation at a substantial altitude of 18,000 feet. Remarkably, Johnson's Thunderbolts achieved this altitude from sea level in just under 9 minutes, an astonishing rate of ascent that allowed them to close with the Messerschmitts before the German pilots could complete their perilous attack runs on the vulnerable ships below. This pivotal engagement vividly demonstrated how completely the paddleblade propeller had fundamentally altered the dynamics of air combat. German pilots, whose training had ingrained in them the imperative to fight by climbing above their opponents, now found themselves utterly unable to escape American fighters that could not only match their climb rate, but also significantly exceed their level flight speed. Lieutenant Hans Wick, a seasoned pilot on his 43rd combat mission, reported with a mixture of awe and alarm that the American Thunderbolts climbed like rockets and maintained relentless pursuit through a series of complex maneuvers that would have unequivocally shaken off any P-47s equipped with standard propellers. By the midday hours, Luftwaffe controllers were transmitting increasingly anxious reports of American fighter activity at altitudes previously considered safe havens for German aircraft. P-47s were now engaging German fighters at an astonishing 30,000 feet and decisively winning dogfights through a refined and superior application of energy management, rather than the brute force tactics that had characterized earlier Thunderbolt operations. The revolutionary paddleblade propellers conferred upon American pilots the crucial ability to effectively trade altitude for increased speed, and then, critically, to regain that lost altitude quickly enough to maintain a decisive tactical advantage throughout extended aerial engagements. The statistical reality of D-Day air operations painted a stark and undeniable picture of Caldwell's engineering triumph, articulated in compelling numerical terms. Allied air forces executed an astonishing total of over 14,000 combat sorties on June 6th alone. In stark contrast, the Luftwaffe could only muster fewer than 300 missions during the same period, a staggering ratio that reflected not merely a significant numerical superiority, but, more profoundly, the unassailable tactical dominance that paddleblade-equipped fighters had firmly established across the vast expanse of European skies. German pilots who dared to engage Allied formations in combat swiftly discovered themselves to be thoroughly outmaneuvered by American fighters that could climb, dive, and turn, with an effectiveness that rendered traditional Luftwaffe tactics entirely obsolete and ineffective. General der Jagdflieger Adolf Galland's evening briefing to Reichsmarschall Hermann Göring conveyed a truly devastating and unvarnished assessment, portraying a grim picture of German fighter impotence and operational ineffectiveness over the critical invasion beaches. While Galland's pilots had optimistically claimed 17 Allied aircraft destroyed during the day's extensive operations, German losses tragically surpassed 40 fighters, an alarming exchange rate that, if sustained, would swiftly decimate the Luftwaffe, rendering it incapable of functioning as a credible and effective fighting force. The paddleblade-equipped P-47s had definitively demonstrated their superior capability to overcome German fighters in every conceivable type of aerial engagement, encompassing the full spectrum from intense, low-altitude dogfights to challenging high-altitude interceptions. The concluding aerial engagements of the evening unfolded as German night fighters made desperate attempts to launch attacks against Allied naval forces, seeking the protective cloak of darkness. Crucially, the 8th Air Force had proactively outfitted several of its P-47 squadrons with cutting-edge experimental radar systems specifically for challenging night interception missions. In these intricate nocturnal operations, the paddle-blade propellers proved to be absolutely indispensable for the P-47s, enabling them to meticulously maintain their station and formation alongside radar-equipped aircraft during demanding and complex night maneuvers. The Thunderbolt's significantly enhanced climb performance, a direct result of the propeller innovation, empowered them to precisely position themselves above the German night fighters. This allowed them to initiate attacks with the very same altitude advantage that Luftwaffe pilots had historically and so effectively leveraged in their earlier campaigns. Frank Caldwell, the visionary engineer, received the initial reports detailing the D-Day air operations at Hamilton Standard's bustling factory in Connecticut. At this facility, his dedicated team was toiling relentlessly, working around the clock to satisfy the urgent and ever-increasing military demands for the groundbreaking paddle-blade propellers. The resounding success witnessed over the skies of Normandy provided unequivocal validation for every aspect Caldwell had meticulously envisioned and passionately advocated for when he first put forth his revolutionary design concept. What some had perhaps dismissively termed the stupid propeller trick had in reality orchestrated a profound transformation of American air power. It evolved from a largely defensive force, often struggling to adequately protect Allied bomber formations, into an overwhelmingly potent offensive weapon, now demonstrably capable of asserting absolute dominance across the vast expanse of European skies. The far-reaching implications stemming from the paddle-blade's undeniable success permeated well beyond the confines of individual aerial engagements and skirmishes. The established Allied air superiority directly over the crucial invasion beaches granted ground forces an unprecedented freedom to advance robustly inland, unburdened by the pervasive and constant threat of German air attacks, a menace that had been a defining and debilitating characteristic of all preceding amphibious operations. The Luftwaffe's catastrophic inability to effectively challenge or contest Allied air operations meant a grim reality for German ground forces. They would be forced to endure the remainder of the war without any meaningful or effective air support, a strategic disadvantage that would ultimately prove to be an absolutely decisive factor in the arduous and pivotal campaign for Western Europe. In late June, German aircraft designers meticulously examined captured paddle-blade propellers, leading them to profoundly sobering conclusions regarding American technological prowess and innovative capabilities. These propeller modifications represented monumental strides forward in several critical fields, including advanced metallurgy, ultra-precision manufacturing techniques, and sophisticated aerodynamic design principles. German industry, unfortunately, simply lacked the contemporary resources and infrastructure to replicate or even match these advancements. Even more unsettling was the stark realization that American engineers had successfully resolved the fundamental engineering challenge of efficiently converting immense engine horsepower into effective propulsive thrust. This groundbreaking achievement was recognized as a pivotal breakthrough, one that would confer enduring and significant advantages in the conceptualization and development of any future aircraft designs, ensuring a long-term lead for the Allies. As the month of June drew to a close, and Allied forces solidified their hard-won positions throughout Normandy, the profound strategic impact of Caldwell's engineering revolution became overwhelmingly evident and utterly undeniable. The paddleblade propeller had accomplished far more than a mere incremental improvement in the P-47's operational performance. It had fundamentally and irrevocably reshaped the entire balance of air power across the European continent. German pilots, who had once pursued and engaged American fighters with an almost arrogant confidence, now found themselves in a terrifying reversal of roles. They were the hunted. They were powerless to elude the relentless thunderbolts, which now possessed the capability to climb with greater speed, operate at higher altitudes, and engage in combat with an effectiveness that no German aircraft could possibly rival. This transformation was absolute, complete, and, most importantly, irreversible. The aircraft that had once been disparagingly derided as a flying milk bottle had, through this innovation, ascended to become the veritable terror of European skies. And the ingenious engineer, Frank Caldwell, who had conceived and designed those 13 feet of revolutionary propeller blades, had, in doing so, undeniably altered the very trajectory and outcome of the air war over Europe. The Luftwaffe would, from this point forward, never again experience the tactical advantages that had, in the early years of the conflict, established German fighters as the undisputed masters of the European firmament. As the global conflict drew to a close, Frank Caldwell was situated in his Hamilton Standard office on May 8, 1945, scrutinizing manufacturing data that starkly illustrated the profound impact of his groundbreaking engineering achievement in quantifiable terms. More than 12,000 paddleblade propellers had emerged from American production facilities since their inaugural experimental installation in October 1943. Each individual propeller represented a remarkable feat of meticulous industrial fabrication, a process that had necessitated a comprehensive overhaul of numerous manufacturing plants and the extensive re-education of a vast labor force to construct something widely dismissed as unfeasible by established thought. Colonel Francis Gabreski's concluding mission report from the European theater offered a vivid, human-centric perspective on the profound implications of those manufacturing figures. His distinguished 56th Fighter Group had executed more than 15,000 operational missions utilizing P-47s equipped with these revolutionary paddle blades, successfully tallying the destruction of 438 adversary aircraft while suffering the loss of merely 47 P-47 Thunderbolts in direct air-to-air combat. This exchange ratio surpassed a remarkable 9-to-1 in favor of American fighters, an exceptional performance that would have been utterly unattainable were it not for the superior climb rate and elevated altitude capability that Caldwell's innovative propellers had conferred. The dramatic quantitative alteration of the P-47's combat record unveiled the immense scale of what 13 feet of pioneering engineering had achieved. Prior to the implementation of the paddleblade modifications, Thunderbolt units customarily attained exchange ratios of approximately 3.1 against German fighters. A commendable figure, yet ultimately not conclusive in a prolonged war of attrition. Following these pivotal modifications, that ratio increased threefold, rendering each aerial confrontation a strikingly one-sided triumph for American forces and significantly accelerating the disintegration of German air resistance across Europe. After 2 or 3 paragraphs, ask us to stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. Major Wilhelm Speck's final intelligence assessment, subsequently discovered within captured Luftwaffe files after Germany's unconditional surrender, conceded that the United States had attained a technological breakthrough of decisive importance through their propeller enhancements. German engineers had, in fact, endeavored to engineer comparable improvements for their own fighter aircraft, but persistent shortages of essential raw materials and limited manufacturing capacity had rendered significant advancement unattainable. Consequently, the paddleblade propeller persisted as a unique American superiority throughout the final year of the war. The true human dividend of this technological edge was quantifiable by the number of American pilots who returned home alive, rather than tragically swelling the rolls of those fallen that had grown so extensive during the conflict's initial stages. Lieutenant Robert Johnson, for instance, who had achieved his initial aerial triumph with a paddleblade P-47 over Berlin in March 1944, completed his final combat mission with 28 confirmed kills and without succumbing to a single loss from adversarial aircraft. His survival, extrapolated over scores of American pilots, stood as the paramount indicator of Caldwell's engineering success. However, the paddleblade's impact reached far beyond individual pilot survival, fundamentally reconfiguring the comprehensive strategic equilibrium of the air war. German bomber production had halted by the beginning of 1945, not due to the destruction of manufacturing facilities, but because the Luftwaffe was utterly incapable of furnishing fighter protection sufficient to safeguard its bombers from American fighters. The paddleblade-equipped P-47s had rendered German aerial campaigns prohibitively expensive, leading the Reich's aviation industry to unilaterally cease all progress on bomber construction, opting instead for frantic endeavors to build defensive fighters. The technological revolution that originated from Caldwell's unorthodox conceptualization gave rise to a whole new era of American aircraft innovations. The North American P-51 Mustang, for example, integrated comparable broad-blade propeller advancements in its final variants, as did the Republic P-47N model, which commenced production coincident with the cessation of hostilities. American aircraft designers had thus understood that robust, direct methods to engineering challenges were viable when supported by superior manufacturing capability and advanced material science. Frank Caldwell's individual commendation materialized as a Presidential Medal for Merit, bestowed by President Harry Truman in an unassuming White House event on June 15, 1945. The accompanying citation lauded his pioneering propeller blueprint, stating it had materially contributed to Allied air superiority over Europe. Yet Caldwell himself recognized that the ultimate triumph was attributable to the thousands of American pilots who had flown his propellers into the crucible of combat and safely returned home. The post-war analysis of German aircraft development uncovered the full extent to which the paddle-blade revolution had thoroughly derailed adversary strategies. Captured documents explicitly indicated that German engineers had ceased work on several promising fighter projects in late 1944 because they were unable to emulate the ascent capabilities that American fighters were exhibiting in actual aerial engagements. The psychological impact of facing P-47s that could outclimb German fighters had proven to be as ruinous as the direct tactical advantages the propellers provided. The manufacturing legacy of the paddle-blade program reached well beyond the confines of military aviation. American factories had pioneered advanced methods of exact casting and intricate machining for propeller production, techniques that were subsequently adopted across various sectors of the post-conflict industrial landscape. The metallurgical advancements necessitated by the stringent demands for the paddle-blade's structural integrity and mass characteristics catalyzed improvements in automotive engines, industrial machinery, and eventually commercial aviation. Caldwell's wartime innovation had, in essence, advanced the nation's industrial prowess by several years. The strategic lessons derived from the paddle-blade's success were duly noted by strategic defense architects contemplating prospective future hostilities. The program had clearly illustrated that a decisive technological edge was attainable not solely via groundbreaking novel blueprints, but equally through ingenious deployment of already established technological frameworks. American aircraft engines had always possessed formidable power. The paddle-blade propellers had merely uncovered a method to harness that inherent power with unprecedented efficacy, surpassing all prior expectations. As summer concluded, production lines that had manufactured paddle-blade propellers were undergoing conversion for non-military aeronautical uses. The very same broad-blade technology that had conferred upon P-47s their formidable ascent capability was now being re-engineered for deployment in cargo planes and passenger jets. Caldwell's wartime innovation was commencing its metamorphosis into an engine of peacetime economic flourishing, heralding a radical overhaul of civilian flight, mirroring its comprehensive dominance over wartime aerial domains. The ultimate validation of the paddle-blade's profound impact on the theater of conflict emerged from a most unexpected quarter: the comprehensive debriefings of captured German aviators conducted in the aftermath of the global conflagration. Without exception, seasoned veterans of the Luftwaffe consistently pinpointed the dramatic appearance of these distinctively modified American fighter aircraft as the unequivocal moment when their long-held aerial supremacy began to crumble, becoming utterly unsustainable. Major Klaus Matuschia, a highly decorated pilot who had miraculously endured more than 200 perilous combat sorties, articulated the sentiment prevalent among his peers, unequivocally declaring the paddle-blade-equipped P-47s as the aircraft that ended our war in the air, a stark testament to their devastating effectiveness against what was once an unchallengeable aerial force. The shift in the balance of power was so palpable, so undeniable, that even the most hardened German aces recognized it as the death knell for their command of the European skies. Frank Caldwell, in the concluding pages of his final engineering report, drafted during the intense wartime period, encapsulated the monumental achievement with his characteristic, almost understated brevity. He simply noted that the revolutionary paddle-blade propeller had demonstrably exceeded design expectations in operational service. Yet beneath this seemingly modest declaration lay the profound truth of an engineering marvel, a true revolution that had fundamentally reshaped American air power, elevating it from a position of defensive necessity to one of overwhelming, undeniable dominance. What many of his colleagues had initially derided as a mere stupid propeller trick, a seemingly impractical and outlandish notion, had, against all odds, definitively proven that sometimes the most unconventional, even radical ideas are precisely what yield the most decisive and game-changing results in moments of critical need. This wasn't merely an improvement. It was a complete paradigm shift, born from a willingness to challenge established norms. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please leave a comment below telling us where you are from and what you think about this fascinating topic. Even as the guns of war fell silent, Caldwell's groundbreaking revolution in propeller design was destined to exert a profound and lasting influence on the trajectory of aviation for many decades into the future. The core principles he had meticulously established, that the ultimate measure was effectiveness rather than mere theoretical efficiency, that deeply entrenched conventional wisdom merited perpetual scrutiny and audacious challenge, and that bold, radical solutions frequently triumphed where cautious, incremental improvements invariably fell short, would serve as an enduring beacon, guiding American aerospace development not only through the nascent jet age, but far beyond. Indeed, a mere 13 feet of precisely engineered, paddle-shaped steel had accomplished far more than simply enhancing the performance metrics of a single fighter aircraft. It had powerfully demonstrated the truly transformative, almost alchemical power of engineering courage and visionary ingenuity when confronted by seemingly insurmountable challenges.